guys, I hope you're doing great today. In today's lecture, we are going to discuss about the Kubernetes terminology. And guys, I have shortlisted around 17 important and most frequently used Kubernetes terms that we must know as a DevOps engineer. So that would be our fifth Kubernetes lecture in our Kubernetes course series. First, we discussed about what is Kubernetes, how Kubernetes works, what is the architecture of Kubernetes, and in the last lecture, we had a deep dive of a Kubernetes cluster in which we discussed and we learned each and every component of Kubernetes in master node and in worker nodes as well. So if I quickly repeat, we discussed the components of master node like Kube API server, Kube scheduler, Kube controller manager, and etcd. Also, we discussed the core components of a worker node like kubelet, kube proxy, and container runtime interface like containered or Docker. So there would be a lot of Kubernetes terms that would be used in our upcoming lectures, like what is a daemon set, what is a replica set, what is a stateful set, what is a config map, what is RBAC, rollback access, what is a deployment, what is a NodePort. So these are actually the most important Kubernetes terminologies, or we can say Kubernetes terms that we must know as a DevOps engineer. And that would be our last theoretical lecture, I would say. And then we are going to proceed with our practical sessions and practical labs in which we are going to install Minikube and Kubernetes cluster as well. And we will see each and everything in practical, how practically each component of the Kubernetes cluster works. So make sure that you subscribe DevOps Molvi on YouTube. Let's get started with Kubernetes terminology, Kubernetes terms we must know as a DevOps engineer. So that is one of my favorite illustration, you can say, how we can quickly learn by watching this picture that this is the most superior deployment into replica set, and pod contains a container. So that is actually a funny thing, but literally it is the core concept. So that's why in this lecture we are going to discuss each term, like what is deployment, what is a replica set, what is a pod, what is a container. After all, we know container while we had a complete Docker course. So rest of the Kubernetes terminologies we must know. So let's begin with our first Kubernetes term, which is pretty easy and really simple. What is a Kubernetes cluster? Which is number one Kubernetes terminology in today's lecture. Kubernetes cluster is a set of nodes managed by Kubernetes. That can be one master node and one worker node, which would be the simplest Kubernetes cluster, or 3 master nodes and 12 worker nodes, which would be the best cluster for high availability and scalability of our applications. A cluster consists of master and worker nodes. A node is like a Linux machine. A node can be a virtual machine on your cloud provider on AWS or Google Cloud Platform. So the set of nodes form a Kubernetes cluster. It is simple and really basic. We know that. And number 2, node. A node in Kubernetes is a physical or virtual machine that provides the computing power to run workloads. A node is a virtual machine, a physical server with Linux running on it. It is a node. If a node fails, it's automatically removed from the cluster and other nodes take over. That is when we have multiple master nodes and multiple worker nodes. That's what I have told you, that in a highly available cluster, we must have more than one master node and we must have more than one worker node. So in case of any failure, the rest of the nodes take responsibility and our applications must not go down at any cost. So a node is a physical Linux server, or it can be a Linux virtual machine. Number 3, what is a pod? And the pod is the smallest unit of execution in the Kubernetes system. Okay, and it is made up of one or more containers. We have pods running on the master node, and we definitely have pods running on the worker nodes. And it is the smallest part, you can say, or unit of a Kubernetes cluster which contains containers. So a pod can have one container or multiple containers running in it, and a pod is the collection of containers that work together to serve a common purpose. What is that common purpose? It is to host, it is to run our applications in containers. Our applications are containerized, and those applications run inside a pod. And pod consists of one or more containers, and it is actually the smallest unit of a Kubernetes cluster. We have pods on all the worker nodes, and those pods are actually managed by the Kubernetes master node API server, and kubescheduler is used to schedule new pods. So pod is actually, you can say, it is the smallest unit of a Kubernetes cluster which contains containers. Alright, so number 4 is namespace. Just like you remember, we have discussed workspace in Terraform. Okay, while we use workspace to isolate our environments. Our dev environment is isolated with staging, with prod. Each environment is isolated. And when our environments are isolated, dev cannot sneak into prod. Prod cannot sneak into staging. They don't interfere with each other. That's what isolation means. And similarly, just like we discussed workspace in Terraform, we have namespace in Kubernetes. And Kubernetes namespace is an isolated environment in a cluster. The resources belonging to different namespaces cannot directly interact with one another. So we will have different namespaces. So for instance, if I want to host my applications using Kubernetes, I can create a separate namespace for my website data. I can create a separate namespace for all the secrets and sensitive information in the vault namespace. Similarly, I can have a different namespace for the deployment. So that's how namespaces work. Namespaces isolate the resources, and the resources cannot directly interact with each other. So if I want to make it more simple for you guys, for instance, if I have two namespaces, namespace A and namespace B. So when I create pods or resources in namespace A, these resources or these pods cannot be accessed by the namespace B. If I am using namespace B, I would not be able to see the pods, the resources of namespace A. And similarly, I cannot see the resources, the pods of namespace B in namespace A. So namespace B will have its own pods, it will have its own deployment, it will have its own service or ingress. So that's how we use namespaces to isolate the resources. I hope that now this concept is clear. Number 5, deployment. What is a deployment? A deployment manages a set of pods to run an application workload. The deployment is a way to automate the process of creating and managing multiple replicas of the application, making it easier to manage, update, and scale our application without worrying about the underlying infrastructure. So guys, in simple words, a Kubernetes deployment is the blueprint for running our applications on Kubernetes. So deployment is responsible for our application's deployment, how our applications should be deployed, what should be the replicas or the copies of our application to make it highly available. And not only that, a deployment actually manages all the set of pods, and we can also roll out our changes using the deployment. And one more thing that we must know, that Deployment is used to create and manage multiple replicas of the application. Now, if we have multiple replicas or multiple copies of the application, if one copy fails, the deployment will replace it with a new one which is healthy and running so that our application runs all the time. So that is how a deployment is used in Kubernetes. In short, it is actually the blueprint of all our applications that run on Kubernetes. These are actually the additional benefits of a deployment. It also manages, updates, and scale our applications without worrying about the underlying infrastructure. And number 6 is service. A service groups pods and exposes them for external traffic as a single entity. In Kubernetes, services are commonly used to expose pods to external or internal traffic. That is actually the definition, the proper definition of a service. But in order to understand a service in Kubernetes, I am the user and my application run on the pods. Okay, now the bridge between me and the pods is actually service. A service lets users to interact with the applications that run on pod, and that's why guys I have shared the simplest code of a service. That's how a service looks like you can see the kind is service and the metadata, and it is my node application, you can see, and it runs on port 80. So a service will help me to access, to reach out my application, node application, which is running on the pods in my Kubernetes cluster. So we can say that service is a bridge and it helps users to interact with the applications that are running on the pods. So that is why a service is a common way to expose pods to external or internal traffic. So that's how a service is used in Kubernetes. And number 7 is replica set. A replica set is a group of identical pods, the same pods running for a specific workload is a replica set. A replica set's purpose is to keep a specified number of identical pods running at all times. This helps to ensure that an application is available and reliable even if some parts of it fail. Now, this is actually how a replica set's code looks like in Kubernetes. You can see we have a deployment. This is a kind in which we have the applications replicas as 3. So there would be actually 3 copies of this application, and this will make our application more highly available and scalable. So if any of the replica fails, there would be another one and our applications will never go down. So that is actually the purpose of creating replica sets. So let me share a really common example of photocopying a document. I have one original document and I will go to a shop and ask him that please I want to have 2 more copies of this document. So in total I will have 3 copies of that document that are almost the same, that look like the same. That is actually what a replica set does. So we will have the 3 copies of all pods that are running the same workload. So from this replica set, I can say that there would be 3 pods that would be running all the time. So that is why we use replica set, and I will have 3 copies of my pods that will run every time, and my application will be accessible without any interruption. So that is actually the most basic code of how a replica sets look like in Kubernetes. Now, what is a config map? A config map is a type of native API object designed to store environment-specific configuration data and share it with pods. A config map is a Kubernetes object used to store non-confidential data in key value pairs. Config maps can be created using kubectl commands or the YAML files. Also, I have given this example of config map in which I have this metadata and there are 2 values like key 1 and its value is value1, and key 2, its value is value2. That's how we can store non-confidential data of pods using the config maps. And it is up to you if you want to use config maps in your configuration, and it will just name the pods and their characteristics or their detailed information. And number 9, Ingress. Ingress means how external users access the application or services. In order to understand Ingress on Kubernetes, you can relate it with as our web proxy. After all, our applications run in containers on the Kubernetes cluster. But how I can access those applications in my web browser? Like if I want to have a blog on my Kubernetes cluster and it runs on DevOpsMolvi.com, I want to type DevOpsMolvi.com, how it can be accessed. And that's where we use Ingress. Ingress actually, it is the mechanism used to present services and applications externally from within a cluster. So external users will access the applications that run on the pods using Ingress. So I will definitely use kind as Ingress. Now this is the metadata. This is my blog, DevOps Molvi blog. This is just a label, and the specification is that I'm using Nginx as my Ingress controller, and this would be my website name, devopsmolvi.com. So if I have a website, a blog that is running on my Kubernetes cluster, it can be accessed publicly on the web browser using the Ingress controller. So Ingress can use Nginx or traffic as well. Number 10, DaemonSet. So guys, you must be worried about the differences between a replica set, a DaemonSet, or a StatefulSet. And they have differences. Replica set ensures that identical number of pods run on each worker node. A DaemonSet ensures that at least one pod should run on each worker node. So that is how we can use DaemonSet, which ensures that all or same nodes run a copy of a pod. So if I have a dozen of worker nodes, DaemonSet will ensure that at least one copy of pod should run on each worker node. As nodes are added to the cluster, pods are added to them. And this is obvious that we know that when nodes are added to the cluster, we will definitely have pods on each node. And DaemonSet is a Kubernetes feature that lets you run a Kubernetes pod on all these cluster nodes, which meet the certain criteria. Every time a new node is added to a cluster, the pod is added to it. And that's what DaemonSet does. DaemonSet has the responsibility to run a pod on each node. And when a node is removed from the cluster, the pod is removed from that node. And when a DaemonSet is deleted, Kubernetes removes all the pods created by it. So these are actually interchangeable terms. Replica set ensures that same number of pods run on each worker node. DaemonSet ensures that at least one copy of a pod should run on each worker node. And after that, we will have a StatefulSet as well that I'm going to discuss in the next slide. And this is number 11, NodePort. A NodePort is a Kubernetes service which allows external clients to access applications by opening a port on every node in a cluster. This service opens a port on every node in a cluster and forwards traffic to the service. So NodePort is actually a Kubernetes service. It is a service so that our external clients can access our applications. And the port range of NodePort is from 30,000 to 32,767, but it is also customizable. In short, NodePorts are a basic way to expose services to external traffic. And number 12, which is easy, a secret. A secret is just like the sensitive information. It is simple, and you all know that a secret can be a username, password, OAuth token, or SSH key, Just like we have secrets in other DevOps tools, a secret in Kubernetes can be your password, your SSH key, or your token. And number 13, and the most important one, RBAC, which stands for Role Based Access Control. RBAC. And it is a security feature in Kubernetes which controls access to resources based on the roles of users and service accounts. Just like we have IAM, Identity and Access Management, on AWS or on Google Cloud Platform, to use to grant permissions, certain permissions to the users, to the service accounts. RBAC, role based access, does the same job. It actually defines permissions that are specified, which user must have what kind of permission and which service account should have that permission. It is all decided by RBAC, role based access control, and we can grant permissions such as to create, update, and delete resources. And RBAC helps secure our environment and reduce the risk of unauthorized access. So it is just like we have identity and access management, in which we grant the read-only access or permissions to the users. If you have gone through the IAM lectures on Google Cloud Platform, you must have a better idea how permissions work on Google Cloud Platform. Similarly, we have RBAC on Kubernetes, which is used to grant permissions to the users and service accounts so that they can create, update, or delete the resources on worker nodes, or they can deploy workloads on the worker nodes. Number 14, annotation. Annotation is just like a label. It is an advanced type of a label. A label is just like we name certain resources. Okay, so you don't have to worry about annotation. You can say that it is an advanced version of labeling. And since we know that a label attaches metadata to the Kubernetes object, each object will definitely have a label. Annotations simply considered as the advanced form of labels with more features, with more characteristic. Annotations can contain more characters than labels. That is actually the difference. Annotations will have more features. It will have more characteristics as compared to the labels, and can be structured or unstructured. So that is actually known as annotation. Number 15, cluster IP. So guys, in Kubernetes, a cluster IP is a fixed internal IP address of the Kubernetes cluster. A cluster IP is an internal IP address of the Kubernetes cluster, and it is used to facilitate communication within the Kubernetes cluster. And for internal communication of the pods or the replica set, it is actually the cluster IP which assigns internal IP addresses to all those pods or replica sets. It also defines one or more ports to listen on, and it uses a target port to forward TCP and UDP traffic to the containers. Now, this is my cluster IP and this is my port. So every traffic coming on this IP address and this port will be routed to the pods running on that cluster. So that's what a cluster IP is used. It is for, you can say that cluster IP is used for the internal communication of the pods or replica sets within a Kubernetes cluster. And number 16, and an easy one, which we all know, a load balancer. A load balancer is also used in Kubernetes to distribute traffic equally to all the worker nodes. Just like we know that a load balancer equally distributes the traffic, but how a load balancer works in Kubernetes, it distributes the request, the traffic coming from the external resources to the multiple worker nodes within a Kubernetes cluster. So that's how a load balancer is used in Kubernetes. And guys, the last one is StatefulSet. We know the replica set, which is a set of identical pods. We know DaemonSet. A DaemonSet ensures that one copy of the pod should run on each worker node. Now, what is a stateful set? It is one of the most important interview questions regarding Kubernetes. Differentiate a replica set, daemon set, and a stateful set. So now the most important one is stateful set. A stateful set is a set of pods with a unique, persistent host name and ID. Stateful sets are designed to run stateful applications in Kubernetes with dedicated persistent storage. And when pods run as a part of a stateful set, Kubernetes keeps state data in the persistent storage volumes of the stateful set even if the pods goes down. So we can say that a stateful set is the most organized form of pods. Each pod will have a fixed name. The pods will run in a specific order. I'm telling you the features of a stateful set where each pod will have a fixed name. All the pods in a stateful set will run according to a specific order or in a specific manner. In a stateful set, pod A cannot replace pod B or vice versa. And the last feature of a stateful set is that each pod will have a persistent data volume, persistent storage, and each pod's data will be stored in that storage. So that is why I have also mentioned here that if any pod goes down, its data will be saved in the persistent storage volume. So guys, let's revise each and every term quickly. A cluster is a set of nodes. Node is a Linux server or a virtual machine. A pod, it is a collection of containers. One pod can have one or more containers. A namespace, the isolated workspace for resources. A deployment, it is used to create and modify pods in a Kubernetes cluster. And a service, in a service, multiple pods act as a single resource. What is a replica set? The stable set of pods. Identical set of pods is a replica set. One replica set can have 3 pods. If I'm defining replicas as 3, so it means that there would be 3 identical pods. A daemon set ensures there is a copy of pod on each node, runs copy of pods on each node. A stateful set manages a group of pods. The pods are more organized, they have fixed names, they have storage, they run in a specific order. A config map is a non-sensitive data, metadata of the pods. Ingress is external access to the services. A secret can be a password or a token. A NodePort is also a Kubernetes service which is used to allow external accessibility of your applications. Role-based access control is just like identity and access management so that users and services can be granted specific permissions. Annotation to label the objects, more advanced form of labeling. A cluster IP is a cluster's internal IP address for internal communication between the pods and replicas, etc. And lastly, we have load balancer, which is used to distribute the traffic among the worker nodes. So that's it guys for today's lecture. Make sure that you subscribe DevOps Molvi. We have discussed each and every important Kubernetes terminology, and now we are going to see every terminology in action in our practical sessions. We are going to learn a lot in our practical labs, and therefore we have covered a lot of theoretical stuff. Now we should learn Kubernetes, all components and terminologies in practical. Make sure that you subscribe DevOps Molvi. I will watch you in our next lecture of our Kubernetes course. Have a good one and bye.